All right, hello and welcome to everyone joining us today for the second session of the 2020 Yale Chemistry Bootcamp. We're pretty excited to have you today with us for this session. My name is Noreen Gentry and I'm a fourth year graduate student in Jim Mayer's Inorganic Research Lab here at Yale, and I'll be your host today. Before we get started, I have a few logistical comments to go over. So please feel encouraged to use the Q&A function at the bottom of your screen to ask questions throughout this webinar and to upvote different questions that have already been asked that you would also like answered. If you would like to address a specific individual, feel free to include their name in your question. And our team will work throughout the webinar to address your questions throughout the talks. And at the end of this webinar, there should also be time for some live Q&A. So this three-part webinar series is designed to give you a sense of what a career in chemistry might look like and some of the considerations to make on your way there. In session one last week, we heard from some Yale professors and alums about potential careers and opportunities. Today, you're going to hear from 4 fantastic graduate students here at Yale about their path to science. And next week, we'll talk about the process of applying to graduate school. All of these sessions are being recorded and will be posted online for future reference. So in many discussions about graduate school and science, people will talk broadly about research, but it can be daunting to grasp how research works, where you can start, and what you can expect in your experience. Research experience is required to enter STEM graduate school for several reasons. And we wanted to highlight that graduate school is very research intensive, so your research experience will not only help your graduate admissions committees evaluate you as a candidate, but it will also help you evaluate if you want to spend the next 4 to 6-ish years in a graduate program where you'll be doing a significant amount of research. And before we go any further, I'd like to emphasize that everyone's path to science and research is a little bit different. So today you're going to hear from 4 different people and see 4 different examples of approaches that other people have taken. But these examples that we're going to share with you are not meant to be a recipe for what you need to exactly do, but we're hoping that they will be some inspiration for you to find a path that works for you and that you can find something that feeds your curiosity. Our speakers will tell us about different research opportunities that they found and took advantage of, and how those steps influence their scientific development and trajectory. Our speakers will also tell us a little bit about their experiences getting their first research positions, the mentorship and guidance that they received throughout this process, the compensation that they received for their research, whether it was college credit or monetary. And then they'll also tell you what you might be able to expect or what things you need to consider as you try navigating this process yourself. And finally, engaging in research will hopefully help you develop more than just technical expertise. You'll have the opportunity to practice identifying and crafting different questions, thinking critically about challenging topics, and communicating your ideas and results to peers. You may even have the opportunity to connect with broader audiences through the literature, writing papers, or through attending conferences. Ideally, throughout this process, you'll also develop connections with collaborators and mentors who may serve as references and guides for whatever future steps you may end up taking. And if you're thinking that you might want to pursue graduate school, I'd encourage you to tune in next week, where we'll talk about tips about the application process and going through the selection process. So without further ado, I'd like to turn it over to our first speaker, Jaylisa Torres Robles, who's a 6th-year graduate student in the Benjamin Turk Lab. So go ahead, Jaylisa. You can. Great.
Sorry, technical issues.
Great.
Okay, so hi everyone and welcome to our second session of the Bootcamp 2020 from Yale Chemistry. I am Jaylisa Torres Robles and I am a first-generation student from Puerto Rico, where I obtained my bachelor's degree in chemistry at the University of Puerto Rico in Calle campus. So my research path started there during my sophomore year after I took organic chemistry. I really enjoyed that class, and so I decided to ask my professor, then Dr. Elba Reyes, if I could work as a research assistant in her lab for credit. So she ended up accepting, and I was able to work there for 6 semesters on the extraction and characterization of, chemical compounds from the plant agave. And doing that, I gained really basic organic chemistry research skills that I have been able to still use now as a graduate student. But I can say that the most important skill that I gained from this first research experience was probably the ability to think critically and read the scientific literature critically with the help of my mentor. That really helped me then and now to develop my own ideas, hypotheses, and also design my own experimental plans. So an advantage of about how I started my specific path at my home institution, for me, was that I really gained a very supportive mentor that got to know me really well and helped me in guiding my path so that I could achieve my professional goals after college. But my scientific path was also influenced by 2 other research experiences outside of my home institution while doing summer programs, which are commonly called research experience for undergrads, or REUs. And so my first REU was during the summer at the end of my sophomore year. And for this, I actually took advantage of a resource that was available at my home institution, which is the RICE program. This program is usually focused on providing students at my home institution with the opportunity to conduct research outside of the university. So they would bring recruiters from the United States to interview us for their REU programs. And so I decided to sign up for one of these interviews, specifically for the NSF REU program at Penn State University. And once I got accepted into the program, they kindly paid for all of my travel and housing expenses. And they also provided me with a stipend that would cover any other expenses during my 2-month stay there. So while I was at Penn State, I worked at the physics department under the guidance of Professor Moses Hung-Wai Chen, doing electrochemical growth of superconducting ferromagnetic nanowires to study superconductive long-range proximity effects in low-dimensional systems like nanowires. And here's actually one of the nanowires that I was able to make that summer. And for me, this experience was actually very key in deciding then that I wanted to pursue higher education. First, because it was kind of like an icebreaker for me, not only because I was exploring interesting new ways to apply chemical knowledge, but also because it was the first time that I got to experience science and do science in a language that was different from my mother language. So it really gave me that confidence that I needed to know that I could do grad school. And other than that, I also received really amazing support from all of the graduate students and postdoctoral fellows that I met there, but especially from my summer research mentor, who was really helpful and really helped me in becoming an independent young scientist. And later on gave me really good advice about applying to and choosing graduate programs. And so outside of the lab, we also had a lot of fun, both independently and through activities that were planned by the program. With my program cohort, I was able to travel a lot to places including the Niagara Falls, New York. We went to Hershey Park, we went to Philadelphia, and I was able also to go to my first scientific conference to present my summer project, thanks to the sponsorship of my mentor from Penn State, who kindly paid for all of my traveling, lodging, and registration for the conference. So in fact, I had so much fun and during that summer at Penn State that I decided to do a second REU the following summer. And I did it by applying online to the Summer Undergraduate Research Fellowship, or SURF program here at Yale. So back then, Yale was at the top of my list for graduate schools that I wanted to apply to. And the reason why I wanted to do a summer program there was because I wanted to see the environment, learn about their scientific culture, and meet more scientists from there, mostly to know if it was a good fit for me to apply for graduate school. So I applied to the SURF program and I submitted the application through the Leadership Alliance website. And it was a normal application. Generally, they ask for a personal statement, 3 letters of recommendation, and a transcript. And then you submit your application. And once I got the offer, the program also kindly paid for all of my travel and housing expenses and also provided a stipend for the time that I was going to spend there. When I was at Yale for the summer, I worked at the Chemical and Environmental Engineering Department under the supervision of Dr. Eric Altman, on doing a surface chemistry project while validating a machine that they had developed in the lab, where you could simultaneously deposit and characterize thin layers of a material on a surface, mostly characterizing through low and high energy electron diffraction techniques, spectroscopy. So here is actually the electron diffraction of one of my samples that I did then. And to me, this project was really fun, and I found it really interesting, but it was a little bit challenging, especially at the beginning, because it was a little bit outside of the little knowledge that I had back then. So it felt very challenging. But it was still a very incredible experience because I also received a lot of support from my mentors and the postdoctoral fellow that was looking over my work then, where they actually helped me to understand everything really well. And I felt like I could ask all the questions that I needed to understand my project. And outside of the lab, I also got a lot of support from my program cohort, who would organize study groups at night so that everyone could learn more about their summer projects. And it was really amazing. But one thing that I really like about the SURF program, other than all the fun that I had doing karaoke and visiting places in New Haven and also going to New York, is that the program actually gave us the opportunity to do a GRE practice test and an NSF fellowship practice, where we actually got to write an entire NSF proposal based on the summer project that we were working on, and got really, really amazing advice and feedback from our research mentors and also from graduate students here at Yale. And so it was a really key experience that helped me later on getting this fellowship when I was a first-year graduate student. And finally, we also got the chance to present our work during the summer in an oral presentation at the Leadership Alliance Symposium, which was also an additional thing that added to the professional skills that we developed during the program. So now, back then, because of the type of research that I was doing, that experience to me was really key in defining what kinds of research questions I wanted to answer while in graduate school. And the 2 experiences that I did during the summer really helped me in deciding that I wanted to pursue more organic and biological research questions going further. So I applied to the graduate chemistry program here at Yale and got accepted, and I am currently a part of the chemical biology subdivision here. And I work studying the specificity mediated by transient interactions and kinase signaling networks, where I am able to use many techniques from chemical biology, biochemistry, molecular and structural biology to answer questions that will allow me to use chemistry to understand biological problems. And I am very passionate about that. So to conclude, having all of these research experience for me not only helped me to grow as a young scientist, but it also helped me to understand that I really liked research and that I wanted to do research going further after college. And it also helped me to decide what kind of research questions I wanted to answer. So all of those experiences was really key in how I developed my path through science. And I just want to reiterate that these are only 3 examples of how I got research experience before graduate school, but there are many other research opportunities that you can explore, no matter the stage of your career that you're currently at. My advice is always that you should start early so that you can experience many different things. But if you haven't and you're almost graduating college, don't worry, you still have the chance. There are other opportunities like post-bac research experience and gap years in industry, which we'll hear later on, that you can do to get research experience. And remember, you can always take advantage of all of the resources provided by your institution or other institutions if your institution is not research focused. So yeah, just get yourself out there, be brave, and you're gonna have a blast with all of these opportunities. And thanks for coming.
Great. Thanks so much for all your insights and for sharing your experiences with us. It's very valuable. If people have more questions, feel free to address Lisa in the chat. But up next, we're going to talk to Kevin Wernke, who is a 5th-year graduate student in organic chemistry in Seth Herzon's lab. So I'm going to turn it over to Kevin. Great.
Great, thanks, Noreen. Yeah, so my name's Kevin. I'm a 5th year in the Herzon lab. So back in 2012, I started college at CMU, or Colorado Mesa University. That school is probably not one that many people have heard of, but it's while it's a university, there's no graduate programs in the sciences. And so my exposure to research at my time there at CMU was purely that of like an undergrad within an undergrad-driven lab. So the PI was a little bit more hands-on. The things we learned were from the professor. There weren't grad students teaching us. And so the research we were exposed to was highly driven towards teaching, whereas I would argue research at like an R1 institution like Yale is focused on publications and sort of cutting edge research and pushing fields forward. During my undergraduate, I also had the opportunity to participate in an REU type program. And so while NSF, National Science Foundation REUs are great, there are also privately funded REUs as well. And so mine was sponsored by the pharmaceutical company Amgen, but Merck and other pharmaceutical companies also sponsor these. So mine was at Washington University in St. Louis. It was there I was sort of first exposed to more cutting edge research, if you will. And so in this lab, we synthesized small molecules, drug-like molecules, to hopefully aid in the early detection of Alzheimer's disease. So a very pertinent problem, a problem that's affected a lot of our lives personally. And so it was really powerful to see synthetic chemistry sort of on the front lines of bettering human health and disease. And it was sort of in that experience that I saw what research looked like that pushed fields forward and made discoveries. And I also saw how chemistry could be sort of used within that. I went back and continued doing research at CMU, obviously, until I graduated. The research there, I should mention, I guess, was biological. So I grew E. coli and I played with amoebas and things like this. Even though I majored in chemistry, I didn't actually do chemistry research until the REU. And so then that brings us to my grad school experience, which is actually in total synthesis. So I made a big jump from biological research, primarily as an undergrad, to chemical, organic chemistry synthesis. And so I guess one thing from my personal journey is, just because you do one thing in undergraduate doesn't mean you have to stay on that path. Keep an open mind. There's lots of different flavors of research. It's kind of like ice cream. If you only eat vanilla, you're not going to know what other flavors there are and what your favorite flavor might be. So definitely expand your horizons as you can in your undergraduate. And so you'll kind of notice that some of the themes are the same. Even though I do chemistry now, it's again looking sort of at how these molecules we're making affect human health in the context of the microbiome and how it might facilitate colorectal disease, colorectal cancer. How did I get these experiences? So by and large, the common denominator is relationships. I was first asked to do research in my freshman year by a professor. I was taking animal biology and she's like, "You seem to like this. Have you ever thought about research?" And I'm like, "What's research?" And I wound up starting because I was pre-med at the time and was told it would bolster my CV, but really fell in love with it. And the rest is, as they say, history. But I also talked to a lot of senior undergrads and, some were pre-med and I saw what they were doing, what they were preparing for. And I saw the senior undergrads that were doing research and kind of fell more in with that crowd and decided that their interests and my interests were more aligned. And from their experiences, I learned sort of what the next steps were, et cetera. Also, again, sort of, I entertained career paths I hadn't previously thought about. I thought I liked science, and the way I can make money as a scientist is going into medicine, but sort of through research as an undergrad, I realized that isn't the only avenue for a scientifically minded person. And then finally, the REU that I got was sort of a luck of the draw in a lot of ways. I applied to a lot of programs and only got accepted into one. And so if you do apply to some sort of summer research program not at your home university, then definitely fish with a broad net. Apply to programs that you think you might be interested in, not necessarily ones you're comfortable with and are familiar with. And then finally, I decided on continuing on with research, mostly because I enjoyed it. I remember the first summer I did research at my home institution and was paid a stipend over the summer. That was pretty sweet because most summer jobs, you don't learn that much. But getting paid to do science was pretty awesome. And that kind of stuck with me. And then the discoveries you make along the way, I can't really describe what it's like to run an experiment and find something that no one's really found out before or known before. And that's a privilege and something sort of fun that you can't do in a lot of other fields. So I think with that, I'll turn it over to the next speaker. Thanks, guys.
Great, thanks so much for your insights, Kevin. Going to go ahead and move forward to Savannah, who will tell us a little bit about her experience. She's a second-year graduate student that is a joint student in 2 different labs, Patrick Holland Lab and also Scott Miller. So she'll tell us a little bit about that experience. So Savannah, you can go ahead and turn on your video. Perfect.
Thank you. So today I'm going to talk about my path to research, which, like many people, began during my undergraduate career, which I did at the University of Maryland. After a couple years of taking college courses, I discovered that I enjoyed both my organic and my inorganic chemistry classes the most. I was interested in finding a research group that might allow me the opportunity to learn a little bit about both areas. So after exploring the research group's websites online, reading some of the literature, and talking to a couple advisors, I ended up joining the research group of Mike Doyle. There, my research involved the use of metal carbene catalysis and diazochemistry, as represented here. One of the biggest components of my education from my time in my undergraduate research was in the lab fundamentals. This was my first time in a lab, and so I learned a lot of the basics in lab skills, safety procedures, and analytical techniques. It also was my first exposure to data communication, which I was able to get practice in both within the group and group meetings and reports, but also externally at a regional conference in addition to a couple publications. While you'll see over the next few minutes that I'm always still learning new things, I fully credit my undergraduate experience for giving me the foundation that I needed for the rest of my career. I also was lucky enough during this time to build a wonderful relationship with my advisor, who was able to provide a lot of advice and mentorship, even beyond chemistry, and still does to this day. Although I very much enjoyed my research at Maryland, I decided that I wanted to try something new and see what else is out there and available before pursuing graduate studies. After applying to a variety of opportunities in industry just online through the company websites, I ended up at the pharmaceutical company AbbVie, where I worked in drug metabolism research. Just very briefly, for those who might not be familiar, the basic idea of drug metabolism is that your body is trying to change the drug, usually by making it more polar, in order to get rid of it. You elucidate the structural changes to the drug by using high-resolution LC-MS data. And in pharma, it's absolutely critical to identify the structures of these metabolites so that you can evaluate them both for potency and potential toxicity issues. So what you're looking at here is the metabolic pathway of the common drug ibuprofen. I share this with you only to show that although I was no longer doing synthetic chemistry as I had in my undergrad years, I think it's pretty easy to see how a background in organic chemistry was beneficial for this role. I had to be comfortable with the structures in order to identify the changes that occurred in the metabolites, But also I ended up working very closely with the medicinal chemists at AbbVie in order to use my data and design better drug candidates. One of the biggest and coolest things that I learned during this time was in the area of new analytical techniques, such as the use of radioactivity and high-resolution LC-MS in order to elucidate metabolite structures. These are techniques that otherwise I might not have had exposure to in my synthetic chemistry time. Another really great outcome of my time in industry was the ability to network, not only within this massive company where I could reach across divisions and departments, but also externally at national and international conferences where I had the opportunity to share my research, both in poster presentations and in oral talks. One of the most important things that I learned for myself during my time here was that it can be really beneficial to step outside your comfort zone. Admittedly, I knew nothing about drug metabolism before I started at my job at AbbVie, but because I was willing to take that risk for myself and learn this whole new field, they were willing to take the same risk for me, and it ended up being a really educational and wonderful time for me. Although I thought that was a really cool research and really cool things to be a part of pharma, my original interests and passions in chemistry from my time in undergraduate still remained. And so I decided that the best way to return to chemistry would be to apply to graduate school. Amongst the many other things that I just discussed, my time in industry also taught me the importance of interdisciplinary science. I found that a cross-functional scientist that's trained across multiple disciplines has the power to break down communication barriers that sometimes exist in daily conversation. And so with all of that in mind, I decided to become a joint student across both the organic and the inorganic divisions here at Yale. So now I'm a second year in the labs of Scott Miller and Pat Holland, where I'm studying the use of chiral peptide catalysts and hydrogen atom transfer chemistry. Like each of the experiences before this, I'm always learning new lab techniques. One of the absolute coolest things about being in two groups is that I'm around twice as many amazing and talented people, each of whom brings their own unique perspective from their own unique research path, and I'm lucky enough to get to learn from all of them. Also, while I mentioned that much of my previous communication experience and my time in industry was oral, in talks, and in poster presentations, I'm finding in grad school a lot more opportunities to practice my written communication and things such as papers, proposals, and grant writing. Being a second year, I'm looking forward to the next couple years and hopefully all of the cool things that I'll continue to get to add to this blue box that I'm learning. And that brings us to now. One of the most important things that I want to mention, like Noreen said at the top, this is by no means a directional. These are the things that I've specifically learned for myself along the way. But the most important thing is that you can forge your own path. It's just important that you get started and get into research. No matter what you choose to do, even if you choose to change your mind along the way, you're always learning, both in chemical and technical expertise. You're learning your hard and soft skills, and you're also learning about yourself and your interests and your own career aspirations. And like all of us, while my future is still to be determined, I know that I will take my personal lessons with me wherever I go. So with that, I want to thank you for your attention. I wish you all the best of luck with everything, and I'd be happy to answer any questions using the Q&A function below.
Great, thank you so much for your insights, Savannah. So feel free, again, keep asking questions using the Q&A function. If you have specific questions for individuals, you can continue to address them. But after Julian, we'll also have an open Q&A. So if you have more broad questions, feel free to ask those. All right, so next up we have a third-year graduate student in materials chemistry, Julian Brundler. So I'll turn it over to you, Julian. Can you go ahead and unmute Julian? You had.
Yeah, thank you, Noreen, for the introduction. I'm Julian. I'm a third-year grad student in the Salzmann lab, which is actually in biomedical engineering, but I'm still getting my PhD in chemistry. So something I wanted to mention briefly is It's not really advertised, but especially in materials chemistry, if you're interested in a lab that is not listed in the chemistry department, so for example in chemical engineering, it's still possible to join a lab outside of the chemistry department as long as your PhD has a sufficient chemistry background. So what I wanted to focus on is yeah, no, it's working. So I wanted to mostly focus on my path to science because I think my path is quite unique. So as you might be able to hear, I'm actually from Germany, so I'm an international student. And so I went to high school in Germany, and after high school, I actually took a gap year and I worked in finance. So I didn't have any background in chemistry. I had some interest in science, but not to an extent where I was 100% sure that I want to major in science. And so during that gap year, I worked in finance and I played semi-professional soccer in Germany. And after a game, a guy approached me and was like, yeah, are you interested in studying in the US? I know this coach and he recruits student athletes to play soccer. And I was like, yeah, sure, why not? And so they offered me a scholarship for this university or this college in Florida called Rollins College, which is actually a small liberal arts school. So no graduate school and pretty much only undergrads. And so my freshman year going in, I was undeclared, so I didn't know what to major in. But after filling out a survey, they actually put me in general chemistry class my first semester. And so I took that class without any expectations, and I actually kind of liked it. I liked the challenge of those chemistry problems, and I was also doing quite well. And then after, during my first semester, after one of my classes, the professor approached me and asked me, yeah, are you interested in doing research in my lab? That research was actually with gold nanoparticles. I don't want to go into detail about the specific research, but I was like, yeah, that sounds kind of cool. Like, I want to work with nanoparticles. So I ended up joining her lab, which turned out was only me and my research advisor and one fume hood, which was actually good for me at that time because since I didn't have any background in chemistry, she was actually able, my advisor was actually able to teach me all the techniques that I need to know. So pretty much start from scratch, and she was really hands-on and showed me all the techniques. And this actually then ended up in my first real research experience where I applied to the summer research program at Rollins, so at my university, where we were able to work for 6 weeks, and we got a stipend, and we were able to work during the summer for 6 weeks in our advisor's lab and get a little bit of research experience. So it was a good start, but at that point I didn't feel like I don't really know what I'm doing. So I continued doing that research during the semester, so my sophomore year, and at that point I also didn't know that you need research experience to get into a grad school. But so my advisor, who was really awesome, she told me, yeah, if you're interested in grad school, you should probably get more research experience so you actually have a chance to get admitted. And so I started looking at programs, and what I found out is, so since I'm an international student, I couldn't apply to most programs because they're NSF funded, and NSF funding is only for US citizens, so I couldn't apply to pretty much all of the programs. There is a small number of programs that has private funding or university funding, so it's possible to still apply to those as an international student, but I couldn't apply to the most common NSF funded programs. And she told me that she actually has a friend at MIT, a professor at MIT she knows, she went to grad school with, and she was thinking of going there the summer of my sophomore year to do her own research. And So I asked her, yeah, maybe it's possible that I can join you and also do some research there. And I was able to convince her to take me with her. And so I ended up doing summer research at MIT that summer. Since I didn't get any funding, I had to pretty much cover housing and everything myself, which I had some savings from my gap year, but that's something I had to do. But that research experience really piqued my interest in grad school, because so I worked in Dr. Jeremiah Johnson's lab at MIT, who's a polymer chemist, and he has a pretty big lab with like 15 people. And coming from a lab where it was only me and my advisor to a lab that is doing cutting edge research was really also mind blowing. Like you actually feel like you're doing something significant, and you have all those interactions with postdocs and grad students. And most importantly, it also showed me how a real, like a big research lab works and how to conduct research. And this really piqued my interest for grad school, and doing my senior year. So after that experience, and during my senior year, I started working on my senior thesis, and that connection was actually able to collaborate for my senior thesis with the lab at MIT. So I was able to do cutting edge research at my small undergrad institution by collaborating with that big lab at MIT. And so next, yeah. And so what you actually see right here, the bottom right, is some of the lab at MIT I worked in, and that's my undergrad advisor that went to MIT with me. And yeah, so I know my experience is really specific to my situation, but I think some general things or general advice I want to give everyone, and I wish I would have known at that point, is I think most importantly, talk to your professors at your school and about joining their lab, just to get like some taste for research. Maybe you don't like it, maybe you immediately say, yeah, I want to go to grad school, but I think you need like some like initial stepping stone, like you need some idea what research is like. And then I think what is really, really important is also get experience at other institutions, just to see like how other labs work. And you also get exposed to other ideas, other research, because I felt like really narrow-minded. All I did was I focused on gold nanoparticles, but I didn't know what else is out there. There's so many other things you can do with not only nanoparticles, but other types of chemistry. And so seeing that at MIT, that other type of research was really interesting. So I think in order to get a research experience, my advice would be first look at IEU programs, so like official programs at schools interested in, and especially the NSF actually has a list of NSF-funded REU programs, which you directly can apply to. But so in my case, I couldn't do that. So I think my other big advice is not only for getting research experience, but even later on, or I guess even when you apply to a company, just reach out to people, like reach out to advisors or labs interested in, and directly email the professor and ask if you can spend a summer in their lab and do research. Maybe 50% of the time they won't respond. You can maybe try to write one follow-up, but I think that's, so if you can't get an NSF-funded IEU program, you can still try to directly contact labs and professors and ask them if they have a spot for you during the summer. And also doing that, you can also try to talk to your advisor and ask them if they know someone. So if they maybe went to grad school with someone, or if they know like a certain lab or professor, if they can connect you to someone, and maybe if they can kind of support your email and help you to get into a lab to get research experience. Yeah, I think that's all I have. Happy to answer any questions during the Q&A.
Great, thanks so much, Julian. Now we are to the live Q&A portion of this webinar. So I invite all the panelists to turn your cameras and mics back on. And we have a few questions that we've flagged already, but please feel free to continue asking questions in the Q&A function, and we'll continue to try to get through as many as we can. So the first question that we wanted to try to tackle is a question surrounding imposter syndrome. So I know in STEM, especially as you get up to undergrad and graduate programs, imposter syndrome is pretty common. So I guess my question to the panelists is, have you experienced imposter syndrome? How have you dealt with that? And yeah, I guess just take it away with what your experience has been and how you've been able to manage that.
I can start if anyone. Okay. So yeah, I think I answered a little bit of the question on the Q&A. Imposter syndrome is actually very common, especially for graduate students, and also especially for people from underrepresented backgrounds and first-generation students. I think that one important thing that one needs to keep in mind is that same thing, that it's very common, and that you're not alone. There are many people surrounding you that are going to be able to help you through it and to help you when you have doubts about your research or doubts about some specific method or doubts about yourself. So don't be afraid to speak up about what you're experiencing. Something that has really helped me along the way with my imposter syndrome is basically looking for mentors that understand where I come from and mentors with whom I could talk to about it. And these are usually mentors that really support me and support my path and has helped me guide my pathway throughout science. So I would suggest find yourself some mentors that really support your pathway and your goals, and also speak up to your peers, your graduate school peers or college peers about it. And you'll see that first, you're not alone and you can get through it. Definitely don't let imposter syndrome stop you from getting all of these experiences, because I know it's a little bit scary before you apply or even once you have been accepted before you go. But I assure you that once you're there, the experience is always going to be amazing and you're going to learn a lot of really new, interesting things and people. So go for it.
And I'll just echo what she shared, but also mention that mentors can be in your advisors or bosses, but they can also be fellow students. You can also find a lot of good mentor relationships within your fellow students or colleagues as well.
Yeah, I mean, I think what helped me was just to realize that other people probably feel the same way. And so like personally, I sometimes feel like, yeah, I don't know anything. And especially when I start reading about a new topic, I think it's common. It's impossible to know everything. I think you can be quite familiar with like a certain topic, but outside of that, it's impossible to know everything. Like just expect that other people might also feel the same way. So it's pretty common.
So in thinking then, another follow-up question, I guess, to this, a lot of times it can feel like there's so much that you don't know and like you're not prepared necessarily for a certain field. How do people approach entering into a new field or taking your undergraduate experiences and applying that to graduate school, like entering into a new area?
If I could go here. I honestly sort of embraced it. If you sort of take your weakness and embrace it, I think it's a little bit easier to overcome. And so when I was changing from biology to chemistry, I was very upfront. It's like, I don't know how to run a column. You know, I can grow amoebas, but I can't run a column. How do I do this? And so I think just embracing that you don't know and really leaning into that, one, helps you learn, but also you're not like, you're not trying to prove anything, right? You're just there to learn, so.
I can also add to this. So as you saw, I did research in very different topics along my path. And I think that one thing that I got from all of those experiences is that I really learned the basics of how to conduct research. And that's a skill that you're going to, it's very transferable. You're going to be able to use that in any research topic that you do, no matter if you're switching areas. You're always going to be able to get a paper, read it, understand what they're saying, think critically about it, and develop some ideas about the question that you're trying to answer, despite the topic. So that's really what you need to learn from these experiences.
That's great. We have another question about, so many people sometimes will go from a bachelor's degree right into a PhD degree. Does anyone want to talk about, in chemistry specifically, why people don't do a master's degree in between, and if you'd encourage people to go straight into your PhD, or if they should be thinking about doing other things in the meantime, based on either your experiences or what you wish you would have done?
I can take that one. So since in the US, so it's quite. I'm coming obviously from Europe, so the PhD programs in Europe are different. You get your master's degree first, and then you get your PhD. It's like separate programs. But here, since you're getting your master's degree after, so when you're admitted to grad school, you're getting your master's degree after usually 2 years, and then you get your PhD afterwards. So personally, I don't think it's necessary to spend to get your master's degree somewhere else first and then apply to a PhD program. I think you can just directly apply for a PhD program since you're already getting your master's degree. Unless you're really interested in exploring other areas of science or of research. So I think one asked the question, if you can get research experience after your bachelor's degree before starting your PhD. It's definitely possible. I don't think it's quite as common in chemistry, but for example, in my lab, we had 2 or 3 postgrad students that finished their bachelor's degree and now worked in our lab for 2 years before they applied to medical school. So it's definitely possible to just do research in a lab after your bachelor's degree and just explore other areas. So it's definitely possible. And I don't think those positions are advertised, but as I said, you can just directly email labs and ask professors if they're looking for postgrad.
Does anybody else have any thoughts on either taking gap time, what people should do during that period, or just generally what to do between your bachelor's and PhD, or if you preferred that you just went right through?
Yeah, I'll jump in. So I know that it's often called a gap year, and for me, it ended up being a gap 6 years. But I think there are a lot of different ways to do it. It certainly doesn't need to be in industry, although that's an option. There are also post-bacs available that you can look into, which are sometimes just a 1 year or maybe 2 year program between your bachelor's and grad school. And so there are a lot of different ways that you can go about doing that.
Great. And it seems like there's been a wealth of different experiences throughout the approaches that you've taken and the different opportunities that you've taken advantage of. Do people have a sense or a feeling of, is the diversity of your research experience more important than the quantity of how much research you've actually done? Is it better to diversify or to really dig in deep to one specific area?
I think it it can vary from person to person. It really depends. To me, I felt like I wanted to explore more research topics because even though I loved organic chemistry and I still love it, at that time I was like not sure if I wanted to do that forever. So I wanted to explore other topics. So I feel like if you're unsure, it's fine if you explore different topics and that will help you decide what you want to do. But if you're like very set into what you want and what you like, it's fine to go in and do the same topic for all of your research experience. That's fine as well.
Do you have any, I guess a follow-up question to this is, do you have any suggestions on how you can tie together various different research experiences to put together either a good package for graduate school or even just in how you can use those experiences together?
Yeah, yeah, and that actually becomes really important once you're in grad school and you're trying to apply to fellowships and grants as a grad student, because you really have to find a smart way to connect everything into one thing. And I think a strategy that usually works for me is basically thinking about what I did in each experience and getting anything that I learned, any skill, either professional or research skill that I learned from each experience that I am currently applying. And I always mention that, for example, in my personal research statement. Like, for example, my work here at Yale in the summer was very engineering. And I don't know any engineering now, but the way that I was able to think about that project has really helped me now in the way that I develop my experiments for biological experiments. So that's something that I really think about and put it into words when I'm applying to grants, fellowship, or graduate school. So anything valuable that you learn from any experience will add to your potential value as a graduate student. So don't leave anything behind.
Yeah, and sometimes things end up connecting in ways in which you wouldn't expect it. If you find something that you're interested in, take advantage of the opportunity.
Yeah.
And sometimes those end up getting pieced together in ways that you wouldn't expect. Another thing that I wanted to ask and bring into the discussion is the idea is research and financial aid. So does anyone want to talk about generally compensation for research, how difficult it is to get either money or class credit, what different things people should be searching for when they're looking for these research opportunities?
I can answer. I think some of these things might depend on the PI of the group that you're interested in. For me personally, when I started my undergraduate experience, I was given the option of taking it for credit or for financial reimbursement. I chose to take it for credit during the semesters and for financial compensation during the summers that I worked there. But from my fellow students, it sounded like some of that can vary by group, but certainly everybody had one or the other, either credit or in financial compensation.
And I will also mention that graduate school is free. So all of us as graduate students here at Yale, we all, our tuition is waived and we also get a living stipend. So once you get into a graduate program, a PhD program, then you don't have to worry about financial aid anymore, which is a nice thing to note. Does anybody else have any other comments on getting compensated?
Yeah, I mean, something that I found out, so in Europe, you actually have to pay for your master's degree. And so when I found out that when you go to graduate school in the US, you actually get paid the whole 5 or 6 years to get a master's degree and PhD. There was also one factor to decide to apply to US graduate schools, because you actually get paid for doing research.
Did you mention, I wanted to mention that you also get paid for your summer programs like the entire thing. And not all of the programs, but some programs will also be able to pay for you to go to a conference and present your work. So that's also a nice addition.
Yeah, that was definitely something that I didn't realize during my first research experiences, is how much money there is to fund either conferences or research and different things in general. Julian, you also mentioned that the difference between the European system versus the US system. Did you want to comment a little bit more on some of the differences that you've seen?
Yeah, I mean, I never went to university in Europe, so I can tell you specifics, but from what I've heard from other people is, so in Europe, you go into a bachelor's program, you directly already apply to a certain division. So you already apply for a bachelor's program in chemistry, for example, and you can switch that. So you're getting a bachelor's in chemistry, for example, and then you would apply to a master's program anywhere in Europe, for example, and you have to pay for that again. I mean, university is cheaper in Europe, but you're not getting compensated for a master's program in Europe. And then you would apply to a PhD program in Europe, and then you get a small compensation, but I think nothing compared to here. So it's just enough to survive in Europe, but here I think the compensation is pretty decent.
Yeah, and I think a key distinction that you made also is the fact that in Europe, a lot of the programs you need to get a master's to then get admitted into a PhD program. Whereas in the United States, a lot of times you go straight from bachelor's into a joint master's PhD program, like you go all the way through.
Yep.
So to begin a PhD program here, you don't need a master's before you start. Is I think something that I didn't realize at the front end of this. I'd like to finish up with one last question of what's something that I'm going to ask that everyone answers. What's something that you wished you knew before you started research? And throughout this process, is there anything that as you look back that surprised you throughout the process? So let's start with Julian and we can work our way through.
Yeah, I mean, since I didn't have that background in science, like I also, like my freshman year or sophomore year I didn't know about grad school in chemistry. So I would have liked to like know more about like the future path or like the opportunities that are out there. Like I didn't know about REUs. I didn't know that you get compensated. I didn't know that you need research experience. I thought if I just get A's, I will get into any program. And so yeah, just more, I don't know, information.
Was there anything specific that helped you get that information? Any resources or just?
Yeah, mostly my advisor. So my advisor was really hands-on, and we met several times a week, and she pretty much guided me towards grad school and like making those decisions.
That's great.
I can jump in. I'd like to sort of echo what Julian said. I also felt that I didn't know much when I started about what options are available, especially for organic chemistry. I think sometimes, at least for me, it felt like pharma is the option going forward if you're interested in industry. And the way I found out what's available was to just put myself in industry. And although it was within pharma, it was actually during that time that I learned about other fields and other options that are available for organic chemistry, because going to conferences, you meet people that are maybe not just from pharma. And but I do wish that I had known that when I started.
That's great. We'll go to Kevin next and then end with J. Lisa.
I was hoping I could go last. I was still thinking about it.
Oh.
I guess one thing, so when I was first looking at a career in science and as I was sort of first beginning, like applying to programs and then my first program away from my home institution and then grad school visits, it was all very overwhelming because I realized I was a very, very small fish in a very, very large pond. And I guess I wish I had known at that point that science in a lot of ways is sort of a great equalizer, in that we're all very, very small in a very, very large pond. And even the people that like seem to have everything together and know the right people and have all the ins and have all the past successes, you know, you start day one on a project and it's the same for everyone. So that I find very reassuring, that we're all sort of in the same boat as we begin this career, this great journey of science, if you will, because it becomes a lot less daunting when you know that it's in a lot of ways sort of the same for everyone on day one. You might think you know a lot of things and you don't actually, and you might think you know nothing and it turns out you actually do. So.
Yeah, everyone has to start somewhere. All right, and Jay Lisa, you wrap us up.
The question was?
Well, I guess, what's something that you wished you knew when you started research? And as you look back at your experiences, is there anything that happened that you didn't expect, or anything throughout your experiences that was?
Yeah, I feel like most of the panelists, I didn't know much about research at all, because I come from a very small university in Puerto Rico with very little funding for research. So to me, coming here during summers and even now as a graduate school was like a whole new world. One thing that I hoped I knew when I got here was that I didn't have to do this alone. So I got here with the mentality that I needed to know everything that is there to know about everything chemistry, and that is not entirely true. And you don't need to know everything, especially about your particular thesis project or your summer project. And there's always going to be people there available to help you. Like, asking questions is actually the most important thing in graduate school. When you have a doubt, don't think that you need to answer it on your own, because there are people surrounding you that might know the answer and might save you days or hours of you looking into the literature. And something that kind of surprised me also goes along the same lines, that I didn't know anything about it, is that I was able to learn that there are very different work environments, and it varies depending on the lab that you are at. There are different mentoring styles, different types of colleagues, and just different ways to communicate with different people. So that was surprising, but it's also a good thing, that there is diversity and a variety of people that you can interact with, and that will help you along the way. So yeah, knowing that is important before you get into grad school, because you really need to make sure that you get into a lab that goes well with your values and your work ethic, and that you get the mentorship that you need as a graduate student.
Thank you so much. Yeah, I think as you go forward in your scientific careers, continue to ask questions, continue to chat with different people. Everyone has a wealth of knowledge, and there will always be different people that know more than what you think you know. So enjoy the process. Thanks everyone for joining us today, and tune in again next week at 3 p.m. Eastern Time for our discussion on how to apply for graduate schools.